Alright folks, in this section we're going to talk about some fasteners. And by fasteners we're talking about essentially connections that are used in fabrication, structural steel, small products, all kinds of things. The things you're kind of used to. Now fasteners can come in the form of screws or bolts, or threaded bolts I should say. However, you'll have a tendency to be dealing more with nuts and bolts than you will with screws in this particular field. So we don't deal with screws too much in this section. However, threading is the same concept. So one of the things that you are obviously used to seeing are these. There are plenty of forms of threaded bolts out there. They come in a variety of styles and shapes, special connectors and those kind of things. Machine screws, machine bolts. It's all about creating a wedge system that both is external and internal, and circular motion pulls it up along that wedge and creates a binding impact. So the standards have been around for a while as far as how fasteners work and what they're called out for. And fasteners are typically based on this concept. If we look, let's just draw one out here. If we were to look at a bolt, that's a horrible bolt, but you get the idea. If we were to look in real close, we would actually be able to see this profile, right? Now, it's a little bit more like this. It's more like, there we go. You'd see this profile where each thread is kind of transitioning in a direction. Now, there's a couple things that are important. For example, the pitch associated with a threaded system, the P per se, is the number of threads per inch. So this is a thread. So if I were to measure off an inch on this bolt, let's say this bolt is 6 inches long, and I took 1 inch and looked at it, the number of these things right here, these little edges that I can count, would be the pitch, which is something we're used to seeing. Obviously we've talked about pitches in weld spacing and that sort of thing. So it's just the number of threads per inch. Now there are a lot of standards in terms of how the thread angles go and how coarse or fine they are, their class of fits and that kind of thing. And we're not really in a class of bolt design, so we don't have to worry about that. But it is important that you at least understand the basics and understand how to identify them on a set of plans, especially the call out. So a couple things that a person's going to have to understand when they see a set of plans and some threaded fasteners are called out is they're going to have to be concerned with things like the overall length of the bolt. They're going to be interested in the diameter of the bolt. Obviously that's a big deal if we're going to bore space in between. We're going to have to understand what classification, what class bolts are in, and if they might be left-handed versus a right-handed. If it's not shown, it's typically right-handed, and kind of how that works. So one thing I will point out before we get into some of those details is there's a difference between a coarse threaded or standard and a fine thread. Fine thread are typically more parts that you'll see with computer electronics and those kind of things, where they have a much tighter pitch or spacing of the threads. Coarse is a little bit larger, threads are finer and can have different types of gripping strength. Which, that's what bolts are all about, really, is the compression effect associated with putting nuts on these. That's running out of space there. But putting nuts on these and actually working it in. So if you have more threads, you're going to have more potential binding power. But let's take a look at some difference. For example, hit my little button here. This is your standard, your UNCs, and we'll see where that comes into play in terms of notes later on. Your UNCs are your unified coarse. Then you've got your unified fine, F-I-N-E is what I'm trying to say. Make sure you understand that. Fine. And then you've got your extra fine, so UNEF. You don't really see these as often. Obviously, they don't even exist in these sizes, but you don't really see these as often. Now, this is a great little chart, by the way. You can download it off the internet or something similar to it. It does at least show you what size of drill hole for tapping you're going to have to provide. But this is what you're more interested in, the nominal diameter of the threaded connector itself. Now, just for the understanding's sake, if we're talking about the nominal diameter, what we're essentially saying is, if we go back to our little thread image there, And I'll draw the other side, a little bit offset. So these are threads. You have your, what we call the major diameter, which is actually the diameter from the very tip to the very tip. You have your minor diameter, which of course would be the distance from here to here. And then you have, you probably guessed it, your pitched or nominal diameter, which is occurring sort of like in the mid of the thread triangle shape from here to here. The only reason I point this out to you is just a little basic understanding. You don't really have to know that per se, but when someone's calling out a diameter, technically they're not calling out the exact maximum size of the threads or technically the minimum. They're right in the nominal zone. So, a little piece of information there for you. Anyway, let me hit that again, save myself some time. So here we have our nominal diameters, and we've got some interesting ways that it's laid out. First of all, you're going to notice that up to a certain size, very, very small threaded systems, you've got them in numbers. So for example, a number 8 bolt, or a number 10 bolt, or a number 16. Then, well, 12 too. Then we switch over to a number, not a number, but a quarter, a 5/16, a 3/8, a 7/16, and so on and so forth. Now this TPI is the number of threads per inch, by the way. Again, not a huge deal for you, but it can be standard. You do actually have a standard 20, which is common for most bolt sizes or nut sizes, which you're going to be dealing with. Like a 1/4 inch 20, very, very common bolt size. If you wanted to drill a hole for it, you'd use a number 7 tap drill, and that would be a standard way of putting in a 1/4 inch bolt. Now, you'll notice that a 5/8 actually has a smaller pinch count. There's only 11 threads per inch, and you can see as you get into larger bolt sizes, then you're getting into less number of threads, especially when you're dealing with a unified coarse thread system, not a fine. Notice the difference on the fine version. These are all the same diameters. So for example, a 1/4 inch actually has 28 threads per inch, which makes sense because it's supposed to be fine, and you use actually a smaller diameter tap drill. Then you can go ultra fine or extra fine, and you get up to 32 threads per inch. So anyway, these are all the same nominal diameters, but your thread count changes, and that's actually what helps to create a standard for calling out certain types of threads. So for example, if I were to call out a thread, hit this button here, make this go away, there we go. If I were to do a design, let's say that I'm giving you a top view of a hole. Or maybe let's just not say hole, maybe let's just say I'm going to give you an assembly view of a couple parts, some kind of assembly. And I'm going to show you that there is a nut and bolt on this drawing. And I want to call out what bolt size we're going to use there. So let's just say it's going to be a 1/4 inch size. So I'd have a 1/4, which is your diameter. Then, as you saw from the chart, I need to tell you what the number of threads per inch is, if we're going to use a coarse or whatever. So we're going to say 20, UNC. Now you may say, well, what kind of just, since UNC is always going to, for a 1/4 inch is always going to be 20, why do I have to add that in? Some you'll find that some people actually will not put in UNC in their details, just because if they say 1/4 20, that's what you're going to be calling out anyway, or that's what you're going to be picking up. It's not like you have another option, because UNF is not going to be 20 per inch. But anyway, that's not necessarily the technical way to do it. Slide on over here. There's more information though. For example, we have a 2 and an A. Now by the way, when you see an A on the end, that means external threads, which that makes total sense. We're actually using a bolt, which a bolt has external threads. You know, here's the bolt. That's a bad one, but there you go. External threads. Now, where do you have internal threads? Well, you obviously have the internal threads associated with the nut. So its threading system is designed to be internal. And so is when you actually take some materials, for example, a plate, and you drill and tap it so that a bolt screws into it. That would be internal. Now, what would you do when you actually had to call that out? Well, we'll see in a second. Now, as far as this 2 right here, this is referred to as a thread class. Thread class. Now, what does the class mean? It actually stands for the tolerance and allowance associated with a certain type. Now, your most common is a 2. But if I were to call out a 1A, that would mean that it is for sure. And what type of thread? That's right. Hopefully you said external, because it is external. And A is an external, B is an internal. And a class 1 would actually have a higher tolerance, and which just means the manufacturer puts more time and things, are tighter, so to speak. A higher tolerance value. Now these classes can go from 1, 2, and 3. However, you're most likely to see in the field pretty much a 2 is your typical version you're going to see. And guess what? Sometimes they even omit this stuff altogether, just because it's so standardized that if you're buying a bolt, you're going to be buying a 2A because it's going to be external and it's going to be your standard class. So, what do we do to sum all this up or kind of wrap it up? It just basically means this. Delete these off real quick. So if I give you a 1/4 inch, 20, notice there's no like apostrophe or anything here to imply inches, it's just assumed. 1/4 inch, 20 pitch, UNC, which is your standard unified coarse, and it is a 2A, which is a class 2 and external. It could also be written this way, 2.5-20, of course they put a 0 there too, UNC-2A. Means essentially the same thing. All we did was really change out the fraction for the decimal value. All right. So that gives you a good call out. So what if it were, let's say, I don't know. Let's say it were a 5/16. So it still be a 5/16. And 5/16, we probably want to check the class on that one. You would actually, the thread count, which is 18. UNC. And probably still going to be a 2A. So that's how you identify. And when in doubt, you can always do an internet search to pull up a nice little chart, save it to a folder, or print it off and have it in your notebook, so you can always find. I keep several different versions of threads and bolt charts in my design files, so that I can always quickly go find what I need when I need it without having to spend a lot of time on it. It's always good to have that notebook. Now, most of my notebooks are digital now, but it's good. I also have field notebooks too. So that makes pretty good sense. Now, how do you do it for a different size? What if it's like a number something? It's not a problem. What if it was like a number 8 or number 10? You can do a number 10 dash, let's see, 10's for 24, UNC-2A. Or they may get rid of the number and just write 10-24 UNC-2A. Okay? So they omit the whole fraction component for the numbers there that you see. Now, how are threads shown on a set of plans? Pretty straightforward. If someone were actually wanting to spend time in drawing out a bolt, they might do something like this. Unless you're actually a company that specifies in making threaded features, you're probably never going to deal with this. But on a set of plans, you might see threads shown this way, where they actually draw a little line like this to represent a threaded feature. Okay? That could be internal or external, doesn't really matter. They're just going to draw a little line in between other little lines to imply, hey, this is threaded. All right? Well, that's a good stopping point. We'll see you on the next one.